Ladies and gentlemen, warm welcome from sunny Berlin. My name is Daniel Stecher, and I'm very much delighted to have another fantastic guest speaker for the Airline Crewing and Operations Enigma. And today we talk about artificial intelligence, the big elephant in the room. And I got to know Toby Benenson via LinkedIn. So we were exchanging a lot of messages and comments on each other's post. And I think in one of my posts, you were then commenting you can only automate with AI what you can articulate. And I think this is spot on. This is exactly the talk today. So everybody in the audience, we agreed that you can raise your verbal questions after Toby's presentation. But if you cannot hold it back anymore, just key it in the chat functionality here, and that we can then pick up these questions. Toby, stage is yours.
All right. Thank you, Daniel. Let me share my screen here. Make sure I'm sharing the right one. All right. Can we see this okay?
Yeah, but looks very small. I don't know whether you are making use of the entire screen because it's in the center and around is a big black frame, at least in my part of the world. I don't know how it is in Saudi Arabia and other parts of the US.
Yeah, it's still doing it.
I can read it. I can read it, but I think 50% of the screen is lost by a big black frame.
All right, let me see what's going on here. Hold on. I might just have to roll with it. I'm not sure what's happening there.
Same. But that's okay, no problem. We can see it.
All right. Daniel, thank you for having me. For those of you who don't know, my name is Toby Benenson. I'm the founder of SafeLight. I started in aviation as a dispatcher. I've spent about 18 years in aviation operations, worked my way into senior leadership and COO roles across charter, maintenance, FBO environments. I'm here to talk about something I think is the most important conversation this industry needs to be having, about decision architecture, how this ties into AI. It's the structure that has to exist to define how AI participates in any regulated operations. Many of you have seen the conversations Daniel, myself, and others have been having. Will recognize my underlying theme here, which is you can only automate what you can clearly articulate. If you take nothing else from this talk, take that. If your organization cannot clearly articulate how a decision gets made, who holds authority over it, what inputs inform it, and how it escalates when conditions change, then AI has nothing safe to operate within. The technology is not the bottleneck. The governance architecture is. I'm going to ground everything I present today in a real scenario I lived. Not a hypothetical, not a case study from an accident report, something that happened to me and my team. Before I do, I want to acknowledge something directly. My background is Part 135 in managed aircraft operations. That's been my world primarily. I know many of you are coming from airline environments, and Daniel's work is rooted in airline operations. So you might be thinking, how does 135 apply to me? How does this story apply to me? Here's what I'd ask you to listen for. Every decision in this scenario has an equivalent in your operation. The difference is scale. In 135, one aircraft, one crew, one owner, one FBO, and the entire decision landscape may fit on a single video call. In airlines, these same decisions are distributed across dozens of people, multiple departments, and interconnected systems. The architecture problem doesn't go away with scale. It gets harder and harder to see. I'm showing you the anatomy of the problem in a setting where every bone is visible. Your job while you listen today is to map it to your own world. And I think you'll find it maps more directly than you'd expect. So we had a Gulfstream sitting on an island in Hawaii. We'd flown passengers out there Part 135 on a charter. This was a managed aircraft, meaning there's an owner who approved the charter revenue on their plane. But operational control sat with our company. The flight went fine. There were no issues. We dropped the passengers off. The aircraft was scheduled to return with those same passengers a little less than a week later. We airlined that initial crew home, and we sent a new crew out 2 days before departure. The captain went to the hotel. The first officer, whose family happened to be on the island, went to stay with their family at a location across the island. The FO had a rental car the company didn't authorize. They didn't tell anyone they weren't at the hotel with the captain. The very next day, tsunami warnings started coming in. The owner was alerted and wanted their multi-million-dollar asset moved to safety. Our company wanted to protect the asset and the crew too. So now look at these decision cards. Is this a Part 91 or a Part 135 revenue flight? Who contacts the passengers, us or the broker? Can the first officer get through traffic across the island before the FBO closes? Who tells the aircraft owner they're a stakeholder in this situation, not a decision maker? Who monitors the 5-hour oceanic crossing after the entire team goes to sleep? What's the crew evacuation plan if the aircraft can't move at all? 6 questions, no SOP covers them. No GOM has a chapter called Tsunami with managed aircraft owner and unresponsive broker. Every single one of these is a decision that somebody has to own. And in the moment, the question of who that somebody is and what authority they're operating under is either designed into your architecture or it's being improvised under pressure. Here's the cascade. Within 2 hours, this scenario required coordinated decisions across 7 functional areas simultaneously. Flight operations, we had crew duty calculations, fuel planning, routing, ETOPS, ETP requirements, performance, and the fundamental question of whether we're planning this as Part 91 if the passengers don't show up, or Part 135 if we are getting the passengers on board, which changes the regulatory requirements, the crew duty limits, and the fuel planning. Maintenance control. We decided to pre-position them on standby for a phone call before any maintenance issue surfaced. Not because there was a problem, because I knew from experience that if something came up during engine start or taxi, the time it would take to cold start, the whole maintenance escalation chain, make the phone call, get them to pull up the MEL, troubleshoot with the crew, that could eat 15 minutes. And 15 minutes could be the difference between the crew being legal to fly or not. So we activated them early. That decision is not in any checklist. It came from pattern recognition built over years. That's the kind of decision that lives in the silence between your procedures. Owner management. The aircraft owner was texting the crew directly. They reimbursed their salaries. The aircraft owner perceives them as their pilots, not the company's. And when their multi-million-dollar asset is sitting on an island with a tsunami approaching, the management agreement boundaries get tested hard. Sales and customer service. The broker was unreachable. When we finally got them on the phone, they didn't want to deal with it. They told us contact the passengers directly, which in our world you never do. That's the broker's client, unless they're a direct client of the company. Reaching out directly can be considered poaching and can damage the relationship with the broker. But the broker gave us permission. So now our sales team is calling passengers they've never spoken to about a potential life safety situation in the middle of the night. Crew safety. We needed a plan for what happens if the aircraft can't move at all. The first officer had an unauthorized rental car. The FBO also offered us a reserve for the crew car. There was a hotel that still had room but was filling up fast. And if none of that worked, we identified the first officer's home, being on high ground, was a backup for the backup plan. FBO coordination. They told us they were shutting down in 90 minutes, boarding things up, sending their employees home to safety. Their business made its own operational decision, completely independent of ours. and it created a hard constraint on our entire timeline that nobody saw coming. Lastly, executive oversight. The director of operations, myself as COO, all on a call together. But here's the challenge. Executives tend to want real-time updates. The owner was texting people, and every one of those communication touch points was pulling cognitive bandwidth from the people making the safety-critical decisions. We had to manage the people who wanted updates without letting that communication management become a distraction. That's a governance problem, not a communication problem. Every one of these functional areas was active simultaneously. Every variable interacted with every other variable. And none of this was documented anywhere before it happened. So let's talk about the gap. The industry has procedures, GUMs, SOPs, checklists, MOMs, SMS safety reports, crew duty calculators, scheduling platforms, audit standards. These define what to do. These don't define who decides. And these do not define under what authority. They do not define what inputs inform each decision throughout the organization. And they do not define how decisions escalate when conditions change in real time and rapidly. So you'll see on the right column says what's missing. What's missing is a structured architecture that maps every operational decision, identifies what inputs inform it, assigns who holds authority, defines escalation thresholds, and establishes where automation and AI can safely participate. The space between procedures and actual decision-making is a silent architecture. The most critical decisions in an operation tend to be the ones nobody has documented, named, or assigned authority to. They exist in the negative space between your SOP pages. The decision to pre-position maintenance control on standby. The decision about who manages the aircraft owner during a crisis. The decision about who monitors a pop-up transoceanic flight after most of the team goes to sleep. None of those were in the manual. They live in the silence. And that silence is where most operational failures originate. So you may not be able to read the quote at the bottom. I know the slide is very small, so I'm going to read it for you guys. The FAA actually validated this principle decades ago at the individual pilot level. They studied something called aeronautical decision-making, which is structured decision-making training for pilots. The results were striking. Pilots who received ADM training made 10 to 50% fewer judgment errors. One operator flying 400,000 hours annually saw a 54% reduction in their accident rate after implementing structured decision-making materials. That was for individual pilots making individual flight decisions. The same principle has never truly been applied at the organizational level. That's what operational decision architecture does. So there are 5 layers in ODA. I'm going to talk through each one using the Hawaii scenario to show what they look like in practice. First, we have the decision map. What decisions exist across the operation? The decision registry. What inputs inform each decision? The authority matrix. Who holds decision authority and under what conditions? The decision logic trees. How decisions branch based on variables, constraints, and risk. And the governance layer, where AI participates, how it's governed in real time, and how the architecture itself evolves. Notice I said where AI participates, not whether AI participates. This is not a framework that says stop and map everything before you're allowed to use technology. Most operators already have technology extensively in their operations. Scheduling tools, automated flight planning, performance calculators, weather platforms. ODA doesn't ask you to stop using those. It wraps governance around them. It defines what those tools are authorized to do, what triggers human review and authorization, and what happens when conditions change and the original authorization no longer applies. And it does that continuously, not as a one-time assessment. The decision map answers the most fundamental question: what decisions actually exist across your operation? In the Hawaii scenario, my team faced at least 9 distinct decisions within less than 2 hours. The dispatcher handling it would tell you about 4 of them, the ones that touch flight planning and crew duty. The salesperson would tell you about 2, the ones involving the broker and the passengers. I saw all 9 because I was operating at every level of the stack simultaneously. Most CEOs and people in my position wouldn't be that ingrained in the execution. And most dispatchers don't have visibility into aircraft owner dynamics, the sales relationships, or the executive escalation chain. So here, let's walk through them. Reposition the aircraft or hold it in place. Part 91 repositioning or Part 135 with passengers. Who contacts the passengers, the broker or the operator? Can the first officer get through traffic before the FBO closes? Who manages the aircraft owner? What's the crew evacuation plan if the aircraft cannot move? And the one nobody was thinking about until it's too late is who monitors this pop-up flight if we execute after most of the team stands down. Most of these decisions don't exist in any GOM or SOP. They live in that silent architecture, the space between procedures where real operational decision-making happens. And you can't govern what you haven't mapped. And you can't hand any of it to AI until you see the full landscape. So once you've identified the decisions, the next question is, what inputs inform each one? And this is the decision registry. Take one decision, just one. The decision to launch the aircraft is Part 135 with passengers, as opposed to repoing it out Part 91. Look at how many input categories feed that single decision. Crew status, duty time remaining, fatigue self-assessment, and the fact that the first officer is at a different location than planned and is stuck in traffic across the island. Aircraft, the fuel load, performance calculations, MEL status, pre-flight completion. Regulatory, Part 135 duty limits, ETOPS, ETP requirements, GOM op spec compliance. External, the FBO closure time, the tsunami warning level, the passenger ETA. Commercial, whether the broker authorized direct passenger contact, whether ground transportation exists at the destination for the passengers, whether the broker even wants to be updated on what's happening. And contingency, the Part 91 fallback, the DO already pre-authorized, the crew evacuation plan, whether a hotel is still available. No single person or system had complete visibility into all of these inputs simultaneously. The decision registry map maps them so the full picture is visible before the decision gets made, not reconstructed from fragmented memory afterward. Daniel, I know you were in a conversation earlier about unified data environments and how they enable AI to participate in operations. I completely agree. Unified data is the foundation. What I'm presenting here is what has to exist on top of that foundation, because unified data tells you what's happening. It doesn't tell you who's authorized to decide what to do about it. This is where it gets personal. In a managed aircraft operation, the owner is a stakeholder when it comes to a Part 135 flight, not a decision maker during operational control. But when their asset is on an island with a tsunami approaching, they are texting the crew directly. They reimburse their salaries. They perceive the crew as their pilots. Unless that boundary is defined before the crisis, it gets tested every time. So looking at the table, we have the flight go, no go decision. Upon escalation in this moment, it sits with the director of operations. Part 91 versus 135 determination, same. Owner communication ran through the COO or account manager. And the role is to inform, not consult. The owner doesn't get a vote on whether the 135 flight launches. Passenger contact goes through sales customer service, but only after the broker grants consent. Crew fitness is a joint assessment between the crew and dispatch. Crew evacuation was a COO safety override. MEL application is joint between maintenance control and the PIC. Every row in this matrix is a decision that somebody made in this scenario. The question is whether those authority assignments existed before the crisis or were invented in the moment. In our case, we had experienced people who knew their roles. But what happens when those people leave? What happens when the 3-year person sitting in the seat at 2 in the morning and the aircraft owner texts the captain directly what's happening with his airplane? For those of you in the airline world, think about the equivalent. The authority matrix in an airline operation is more complex because authority is distributed across more roles, more departments, more union agreements, and more regulatory jurisdictions. But the same question applies. When conditions change rapidly, does every person in the chain know exactly what they're authorized to do? What requires escalation? And where their authority boundary ends? Or does that get improvised under pressure too? The FAA's pilot handbook recognizes 3 timeframes for risk processing: strategic, deliberate, and time critical. Most people operate in one of those at a time. The person orchestrating this scenario is operating in all 3 simultaneously. Strategic, pre-positioning maintenance control on standby, building the crew evacuation plan if the aircraft couldn't depart, and identifying the first officer's family home as a fallback before any of those contingencies were needed. Deliberate, analyzing whether the flight met Part 135 compliance, running the FRAT, evaluating fuel and routing under both 91 and 135 scenarios. Time critical, tracking the first officer's ETA through traffic against the FBO closure. Watching crew duty time count down in real time. Every branch point in a logic tree is a risk assessment. The architecture defines what inputs feed that assessment, what thresholds trigger escalation, and how constraints are ranked when they compete. In Hawaii, crew safety outranked crew legality. Crew legality outranked FBO timing. FBO timing outranked passenger availability. That constraint hierarchy wasn't written anywhere. It was applied instinctively by experienced people under pressure. ODA makes that constraint ranking explicit and repeatable. Look at this branch. Passengers confirm? Yes, it's now a Part 135 departure. 14-hour crew duty limit, full 135 compliance, FRAT completed. No, passengers aren't going to make it. Part 91 repositioning. At this point, we may have waited long enough for the passengers. The crew is going to exceed duty. Now we have a DO pre-authorization for extended duty, and that's accepted by the crew under Part 91. The aircraft can't depart at all. Maybe they have a maintenance issue right at departure time. Crew evacuation via rental car to the first officer's family home on high ground or the hotel if there's availability. The Part 91 fallback, as I mentioned, was pre-authorized before anyone knew if the passengers would board. The branch point was defined before the team reached it. They didn't scramble to figure out what authority applied under which condition. That is decision architecture, not improvisation. And here's something most people miss. The most dangerous moment in this entire scenario was not the tsunami warning. It was when the passengers called back and said they'd be at the airport in 30 minutes. Everything was falling into place. The crew was moving. The fuel was loaded. The plans were ready. And the natural human response was to celebrate. Relief, adrenaline, the sense that the problem is solved. This is exactly when focus has to hold. Plans coming together is not execution. One of the most hazardous attitudes in pilots is invulnerability, the belief that bad things won't happen to me. The organizational equivalent is the moment the team assumes the mission is successful before it's complete. If something falls apart in that window, the adrenaline crash combined with premature celebration creates the conditions for the worst kind of errors. The mission doesn't end until the mission ends. Now we come to the governance layer. The governance layer is not just about authority boundaries. It's about protecting the cognitive capacity of the people making the critical decisions. In the Hawaii scenario, Every communication touchpoint was a cognitive load spike. The owner texting the crew directly, the broker needing updates after refusing to help, the executive wanting real-time status updates, the salesperson switching between passengers and broker. Every one of those interactions pulled attention and mental energy from the people making safety-critical decisions. And then, after the aircraft launched successfully, most of the team stood down, except for the dispatcher and the crew flying. We went to sleep. One dispatcher was left monitoring a 5-hour oceanic crossing alone. If something happened in the third hour of that flight, that dispatcher has to cold start the entire escalation chain. The DO was asleep. Maintenance control had stood down. And the dispatcher was alone with a tracking screen and a phone. Nobody calculated the duty time of the people on the ground who made the whole thing possible. The crew had their duty time tracked to the minute. The ground team that orchestrated everything, there's no regulation in Part 135 for that. Airlines, however, live within this constraint. This is where the governance layer defines AI's role. AI can monitor inputs, present variables, track timelines, document decisions in real time, and flag threshold breaches. AI can help keep the situational awareness alive at 3 a.m. when most of the human team has stood down. AI cannot authorize the flight. It cannot assess crew fitness. It cannot manage an aircraft owner. It cannot override the DO. And it cannot make the safe, legal, smart judgment that requires the full context of a human situation in this case. Governance defines who gets briefed and when, what AI monitors continuously, and how the architecture evolves after every operation. Somebody I respect in this industry taught me a framework long ago I've used ever since. Every operational decision has to pass 3 tests. Is it safe? Is it legal? And is it smart? Just because something is green on paper does not mean it is safe. The crew is legal on duty time. The fuel works. The weather is flyable. But the first officer was off station without the company knowing. The crew is self-assessing fatigue in the middle of a tsunami evacuation with adrenaline running. The FBO might close before fueling is complete. Legal does not equal safe. And just because it's safe doesn't mean it's smart. Smart accounts for timing, for the FBO closure window, for the crew's cognitive state after hours of high-pressure decision-making, for what happens when the team celebrates too early, and for who monitors the flight after most everyone goes to sleep. The FAA identified 5 hazardous attitudes in pilots: anti-authority, impulsivity, invulnerability that we just touched on recently, macho, and resignation. Every one of those has an organizational equivalent. The operator who deploys an AI scheduling tool or agent without mapping decision authority first is exhibiting enterprise-level impulsivity. Do it quickly. Don't stop to think about what you're about to do. The operator who assumes their operation will never face a scenario like this Hawaii one is exhibiting invulnerability. It won't happen to us. ODA is the organizational equivalent of the ADM training that the FAA proved reduces judgment errors by up to 50%. Except it operates at the enterprise level across every function that touches operational control. ODA is not a binder that goes on a shelf. It's not a one-time consulting engagement that produces a document nobody reads. It is a living framework that compounds institutional knowledge with every operation it supports. So walking through each column here, let's start with operate. Decisions are made within the architecture. AI can monitor inputs, present variables, flag thresholds, and support the people making the calls. The architecture defines the boundaries. The humans decide within them. Capture. Every decision, escalation, input, manual override by a human, and outcome is documented in real time as operations unfold. Tacit knowledge. I know Daniel has talked a lot about this. The things a 20-year dispatcher knows but struggles to put into words starts to become visible and structural. And the manual overrides are the most valuable data points of all. Those are the moments when human judgment said the system says X, but the right answer is Y. Every one of those captured is a decision logic tree being refined. Compound. Each event refines the maps and logic trees. A 3-year dispatcher becomes a 15-year capability in a fraction of the time because the architecture has been learning too. You might notice something, that these 3 words spell OCC. Operate, capture, compound. I swear to you, that wasn't planned, but it probably should have been. Because that's the cycle an operations control center runs every day. The difference is ODA makes that cycle structural and persistent instead of relying on the memory of whoever happened to be in the room that night. Daniel, you've written about the small percentage of operational outcomes attributable to human factors. Part of that isn't a competence problem. It's a knowledge transfer problem. The 3-year dispatcher isn't making bad decisions. They're making uninformed decisions because the architecture that would inform them doesn't exist outside the senior person's head. ODA doesn't make a 3-year person a 20-year person overnight. That's not what this is intended to do. It's compounding. It makes them a better informed 3-year person who makes decisions that look more like a 7-year person's. And as the architecture compounds over time, that gap keeps closing. Not just because the person gained more experience, but also because the architecture gets smarter too. The post-mission debrief shifts from trying to reconstruct what happens from everyone's fragmented memory to reviewing the documented decision trail logs and identifying what to change in the architecture for next time. The framework learns from operations the way the FAA proved pilots learn from structured decision-making and training. Except it doesn't leave when someone retires. It doesn't leave when someone changes companies. And it doesn't leave when the person who orchestrated the Hawaii scenario from midnight until 2 in the morning decides to start their own company. So why now? 5 reasons this conversation is happening now and not 5 years from now. ICAO working paper, A42WP621. I know that's a mouthful. IFALDA went to the 42nd ICAO Assembly and called for harmonized dispatcher standards and human oversight requirements for AI-assisted dispatch systems. The governance gap is now on the international regulatory agenda. This is not theoretical. It's being discussed at the highest levels of international aviation safety. The EU AI Act. Safety-critical AI systems in aviation now face mandatory governance requirements in Europe. Operators deploying AI without documented decision authority structures face regulatory exposure. This is coming to the rest of the world. It's not a matter of when. It's not a matter of if. It's a matter of when. Agentic AI. We're past the point where AI just answers questions and makes recommendations. AI agents can now execute multi-step workflows autonomously. If the decision architecture isn't mapped before agents start acting, you've handed over authority by default to a system that doesn't know it has it and can't be held accountable for using it. Platform proliferation. Every technology platform I've seen builds the execution engines, scheduling optimization, route planning, maintenance prediction, crew management. These don't supply the governance architecture for decision-making that the engines require. Every single one of them assumes somebody else has done that work at the organizational level. Nobody has explicitly. Knowledge attrition. The people who carry this institutional knowledge in their heads are retiring. Every departure is a permanent loss of decision architecture that was never documented. You cannot hire a replacement for 20 years of pattern recognition, but you can start capturing it and articulating it in architecture before it walks out the door. You can only automate what you can clearly articulate. As I mentioned, every technology platform in aviation is assuming the governance architecture already exists. ODA is building it because it hasn't been. And it governs continuously, not just before AI is deployed, but every time a decision is made within the operation. If you've lived a version of that Hawaii scenario, and you know that the decisions your team made were carried by the experience of the people in that room and not by any documented structure, I really hope this presentation resonated with you. Thank you, everyone. Thank you, Daniel, for facilitating these crucial discussions. That's the end of my presentation.
Thank you, Toby. I believe this was really an amazing presentation. Maybe you stop screen sharing because then we see you even larger. So what I like very much is that you were also talking about the cognitive load of the users in the OCC, because I believe many people are not aware what they are doing with their own health while working with the current setup and with the fuzziness of decision making and so on. So when you are now approached from, let's say, an airline who likes this concept and so on, what would be your recommendation for the initial steps to go? What do you believe is necessary in terms of timeline and also resources? You can take any airline you like to give us an indication, because I think at the end we talk about also the human factor. So we need to ask the people, what is your Hawaii experience? What have you done here and there? And my experience is that people have big difficulties to really articulate what they are doing every day, which is astonishing. You know, on one hand, they say, I know everything and I'm the expert. And if it's okay, please, expert, write it down. They always come with exceptions and it's difficult for them. So what is your recommendation to go the first baby steps and in order to maybe improve over time?
Yeah, this absolutely requires engagement with the experts. And it's important that they feel that this is an effort to support them and get their buy-in to it, not just the inherent distrust I think a lot of operational people have about technology and things that are maybe going to replace us. That's not what this is. And to get their engagement, it starts with having earnest conversations with them and engaging them at the level where somebody has lived this. In my experience in working with operators, you get them to open up and recall a lot easier when they can relate to the person that they're talking to. And when they start to recall this, it's not perfect. Even myself, who could see all the variables that I could remember in mapping out in this presentation, there's still gaps in there, right? I said 9 decisions and here we're mapping out. That's still my that's still my memory. There could have been 10. So it's important that you get a baseline and you're interviewing. That's where I would start, where an operational expert is able to interview with them. You've done a lot of this in sitting down with the OCC folks, talking to them. So it starts with the baseline, getting it out of their heads to the best of their memory, understanding really the ambiguous situations, the one-off scenarios. Get the most impactful things, because when they were really impactful moments like this Hawaii situation, I remember the details a lot more vividly. But a dispatcher may only remember 6 of those 9 decisions. The scheduler maybe remembers 1 or 2. And the gate agent maybe remembers the others. And so it's important to do that interview with all of them and then bring them together for a roundtable and bring it together and have them talk it through with each other, map that out. That's still just the baseline. The real work comes from this getting smarter and building over time in real time and seeing it and observing it and getting them to treat this like a living architecture that gets updated. And really, it starts with interviews and mapping it out with everybody, looking at manuals, looking at scenarios where decisions didn't necessarily meet the guidance in the manuals, finding those discrepancies, because that's the silent architecture that needs to be mapped.
I believe we don't see the tree in the forest, because what you were just describing, and earlier in your presentation we were talking about, we are measuring the fatigue level of pilots, but not from the people on the ground. And if you look what's going on in the cockpit, we have the voice recorder, we measure everything. So I'm astonished why we are not recording the communication on the ground, because what you were just describing, oh, the dispatcher could only recall 6 out of 10. That would exactly eliminate this issue, because we have a recording. So that would be put a voice recorder in the OCC and just record the entire communication. And next one, what do you think about using AI in order to make a first cut of all the analysis of decision tree and factors, and then presenting it to the experts? Say, is it almost 80-20 like you need it? And then I think we are not starting from scratch. We just have to close really the gap maybe to an almost perfection on the ground. So that would be my recommendation, to consider black box and voice recorder in the OCC.
And what I'd say, to add to that, this framework, this patent that I built, has the active governance engine, the runtime enforcement, AI repository concepts. Productizing the technology layer is part of the roadmap, but the architecture has to exist first, and the technology can be built to operate within it. Just as you said, whether it's voice box, there should be an embracing of what AI can do. It's not going to help anybody to pretend like AI is bad and we shouldn't touch it. It is here, and it is actually very effective at doing some incredible things. And if it knows the architecture in which it can operate, what it's allowed to do and what it can't do in this architecture, it can plug into this and work in a way that continuously monitors what's happening, gives the feedback, and then a human can look at this and decide if that's going to refine the architecture and make it better for next time.
Jeff, you raised your hand.
Yeah, thanks, Toby. Thanks for a great presentation, and Daniel for sponsoring this or putting this together. Really appreciate it. Couple questions. One thing is, what I notice is it seems as though, I may have different words for it, but it seems as though you're helping to inject wisdom into the team. I always think of training as teaching somebody how to do the job, but a 10-year dispatcher is better than a 9-year dispatcher, 11-year dispatcher better than a 10-year dispatcher, and that's because of wisdom that they've gained over time. So I think that's really interesting, the approach you have there. A couple things. One of the big things that I always concern myself with any organization is the cultural aspect of it. I think, Daniel, you touched on that a bit, which is, how do you get buy-in? How do you make sure that they understand they're valued? Because as you know, dispatchers from the very beginning of time, and other people's other roles as well, it's just the majority of my experience has been in the dispatch world, have always been leery of anything that is going to do their job for them, right? And at whatever level, another human, they'll push back and say, no, don't touch that. That's mine. What are your thoughts on embracing the culture and trying to make sure that there's still a good, positive culture, and people are happy to go to work and they're happy with the products you're talking about?
Well, I would start by saying I've lived in this world for so long. I'm not just the executive coming in and pushing something on people. I've lived this. I've built the operational control systems. I've been the dispatcher. I've lived alongside all of these people in the trenches. So the first place it starts is building trust with the person that's talking to them about this, and knowing that they understand their human condition and what they're going through. People tend to distrust technology. They distrust anything that they don't understand. And they further distrusted if it's unclear how that's going to affect their control. I think that's one of the biggest things I've seen in an operational setting, from director of operations to dispatcher to scheduler. If they perceive that something is being introduced to them that changes their control in any way, there's distrust. And so we need to help paint the picture with them that this isn't a change in control for them. This is something that is going to make things more visible for them, make their jobs better. I think the dispatcher who is dealing with a 3 a.m. situation and scrambling, in my case, in the 135 world, it's 15 different tabs you have to open up on your browser and 3 different phone calls you're making. And you make one of those 3 phone calls and they say, no, call that other person. And now you're jumping to call the other person. It's the desire to have that streamlined and be a significantly less stressful event in one's job should be desired by everybody. Nobody wants to be incredibly stressed, but they also don't want to become less valuable to the organization. So if we can phrase it to them and create the culture of understanding that this is something that is going to make them more valuable to the organization and give them superpowers in a way that just keeps increasing their value and keeps making them a better expert. Somebody who is a 10-year dispatcher should want to be a 15-year dispatcher in a fraction of the time. So it starts with building that trust on a human level. I think that is really the part that AI can't replace, is earning trust by understanding the human condition and making that connection with people that you understand their fears about the technology and what's being introduced to them.
Thanks, Toby. That's great. I think of like a checklist in a cockpit. The value of the checklist is the items on the checklist. I think sometimes are not as important as the value of the discipline of using a checklist, right? So that's as valuable as the actual checklist. And I know for me, for a previous carrier I worked for, we did try to develop a QRH for the dispatch office, and it really helped a lot. But it's analog. It's not as organized as well because we used to have the time. So yeah, that's great. And I do like the idea where we're trying to help you do your job better, just like Daniel's tools. I mean, there's not taking the authority away from any one person. It's giving them a tool to be able to operate and do more with just that with the same amount of time. So anyway, all right, I'll stop. Thank you, Toby. Very great. Loved your presentation and love to learn more.
Thank you.
And Jeff, adding my 2 cents to your question, I remember last year, I think in September, I published a thought-provoking article in LinkedIn that by 2030, there will be a bloodbath in the US SOCs, and there will be no dispatchers anymore. Everything will be AI. And this LinkedIn article landed in jetcareers.com, where plenty of dispatchers and pilots were starting to debate. I got a push because I have some Google alerts. I said, well, what's going on there? And then 87 comments later, I made an analysis about the mindset of the people debating about my article. And I was then publishing another article that I suggest, because I expect a huge pushback from the unions, not only from the dispatchers, but also from the unions, because we will have less people required to cover things. And this is, of course, a power base for the unions. So my suggestion was to agree with the revenue share model with the airlines, because, of course, the big desire is to reduce cost for the airline and have a revenue share model with all the unionized dispatchers, which will be needed to train the model. So we need these experts to train the AI models, and that they can then get retirement funded from this AI machine. They can sip their cocktail by laying at the beach, having trained the model, being early retired. So it's a win-win-win situation. Unfortunately, this article was not landing in jetcareers.com, but I think this is something where the industry needs to think forward, because we will need these experts. And on the other hand, we will not avoid that we will have efficiency gains with the AI, but I think it doesn't make sense to try to block it. Sure, I think every dispatcher should embrace it and be the expert for this joint project. Nolan, you
Thanks.
raised your hand.
Hey guys, yeah, thanks for putting this on. I really appreciate it. Some fantastic points here. I caught Toby looked at one of my polls for business aviation the other day and invited me to this webinar, so I really appreciate the invite. I've been in aviation now, various different areas for about 20 years. AI in aviation, while highly regulated, is inevitable. And as much as Daniel, you posting your article and getting the ire of the dispatcher community, I think that type of critical thinking is required. If you look at a lot of the tools that a lot of the eVTOL companies, whether they're successful or not, I'm not going to debate that in this, but like if you look at a lot of the tools that they're building to do dispatch from the ground up, and if you look at like even things that Boeing is doing with Whisk and things like that for a human on the loop as opposed to a human in the loop or something like that, the use of AI tools and digitally native solutions are so much more efficient and effective at maintaining situational awareness and keeping us informed of what's going on. Now I'm looking at this from the position of like business aviation, and like from Jeff's point of view, SOPs and checklists and all that lovely stuff, and because I've worked at an OCC at an airline, and it's leaps and bounds different, and the regulatory hurdles are much higher than in business aviation. But your example of the Gulf Stream trapped in Hawaii with a tsunami warning is just as relevant, and there's a lot less structure and a lot more wheels that need to turn that aren't necessarily automatic that then need to go. What I find interesting about this approach is that you're so in tune with the regulatory side and you understand where things are going. And so I learned a few things here myself.
That's great.
But my question is, when you introduce it, whether you're doing it for a business aviation company where the data is less structured, or somewhat more structured at an airline, how are you going to get access to the various different vendors' data that an airline or an operator employs? Because we all know they're super siloed, even though they're connected through APIs. They all are flowing data in between in different environments simultaneously. So what's the trick there?
It's a great question. It really depends on what the data is that we're trying to bring in, because this is more of an internal operator thing that needs to live within the operator's architecture that defines how the vendor is interacting with them, not necessarily making decisions based on their data. That's really an input. So you would identify the inputs that goes into the architecture. And then from there, that evolves into how is the architecture living and what do the vendor inputs. And examples like the FBO coordination. It's very difficult to build into the architecture exactly that, the decision of an external vendor that's not part of your organization was an operational decision to shut down their doors and close their FBO and not fuel any aircraft when we're trying to emergency evacuate. That's not necessarily predictable, but after it happened, now it kind of becomes that FBO coordination. You reach out. The vendors are so dynamic and so fragmented, specifically in the business aviation industry. We could be going to an airport tomorrow that we've never been to before. Mm-hmm. And that's, an FBO need to talk to, and everything is all good. And then 15 minutes before departure, you find out that the FBO ran out of fuel. Their fuel trucks broke, and now they don't have over-the-wing capability, or whatever. So it's very dynamic, and it's less about mapping out specifically external vendors and identifying them as constraints and inputs that exist in the external structure that feed into your architecture in the company.
Okay.
Nona, let me add my 2 cents from IT vendor perspective. Of course, we always face this question when we're implementing our iFlight platform, for example. So we always recommend to have an enterprise service bus, which is then taking the lead for integrating various systems, converting it, sending it exactly then to the other systems. If you don't have an enterprise service bus yourself, our company, for example, is providing such an integration layer. But I think this is also now a very important topic because, Toby, you said earlier, make the first step. Don't expect the perfect solution in the first phase. And I think this is where I see the biggest blocker, because the tendency in our industry, based on the personality types we have in the industry, people know that I'm always talking in colors, but we have a lot of blue people, very accurate in the details, analytical. And then, of course, we have this concern, never compromise on safety. And there's always the fear, if something is missing, operations stand still, there is a issue and so on.
Well,
but I think would be.
You also can't always blame the AI, right? Because there's no one's neck to bring there, right?
Yeah, but on the other hand, I see always 4 reasons if we get an RFP, 4 reasons which are somehow deciding the process. So there is a regulation, and I think Toby touched about it. Regulation. There is the company business rules or business requirements. Then there is the technology in place, which is creating workarounds or limitations. And then I call it the local kingdoms, the local know-how of some old gits who are there since hundreds of years and who always expected already 20 years ago, the button must be there. If not, I cannot work on blah, blah, blah. And I think if you are just making the analysis of your current process and you exactly explain why this data is needed or from where is it coming, maybe it's also creating exactly a good overview. If you are not getting the data today from the system, maybe it's coming from another source, or maybe you are realizing it's crap data. We don't need it. We carry it since many years, but it's like the crap in the cellar. You move to another apartment, you just carry your stuff from the cellar and the other cellar, and it just costs you money. So that's, I think, is my answer to it. Use an enterprise service bus, use an integration layer, make an assessment which data is really mandatory, which is nice to have, and then optimize on the fly. Of course, there is minimum data requirements, and then you build this ecosystem around, but I think it's an opportunity to bring your house in order.
Sure. And if I could just add one more thing, it maybe a little more eloquently to answer your question. My framework, the ODA doesn't specifically solve the data fragmentation problem. It tells you what data matters for each decision. And once you've mapped that decision architecture, and again, this is somewhere to start. We have to start somewhere in both industries with this architecture. And once you've mapped that decision architecture, you'll know exactly what inputs are needed for each decision and from which sources and for which decisions. That starts to become the requirements document for any integration effort. Right now, most operators are trying to integrate systems without knowing which data points they actually need to feed which decisions. They're connecting pipes without knowing where the water needs to go.
Okay. No,
is there so much, any other question in the audience?
Quiet crowd.
So, Toby, again, I think this was a fantastic. Ryan has a question. Okay. Ryan.
I apologize. Being late for asking. Toby, much appreciate your kind presentation. It was very inspiring, actually. And nowadays, an AI, it is a great tool to help you in the daily process of, even if you're working in the severe areas. But I have a question, like my organization serve different type of regulation. Like we have 135 and 121 schedule, and the regulation here, it's deviate the crew limitation duties and And yeah, how we can how your product you think it can deviate this two type differently?
If I understand your question correctly, you're asking how does this apply to different regulatory environments beyond just maybe 135 or 121? The short answer is because this is a framework that is not just rules that are based in one regulatory framework. This is organizational specific. This is built so that it's mapping the decisions in your organization and how those are affected by your regulations. Those are constraints, those are inputs, those are boundaries that are shaping the decisions that you're mapping in your organization. So it's universal, it's fluid, it's dynamic. It has to be unique within the organization that it's in. It's not just, hey, here's Toby's framework and sorry, it's only built for 135. That was never the intention. In fact, I built this to be really more encompassing too. My experience is deeply rooted in business aviation, DOT 380, public charter, where I was at JSX. I know the airlines, but this actually applies to regulated industries too. This is healthcare. This is legal. This is safety critical and regulatory heavy industries where they need framework like this, like the EU AI Act basically says, depending on the level of risk of the AI that's being introduced into the organization. So hopefully that answers your question.
So just if I feed it with the boundaries of each regularity is going to be follows.
Yeah, I understand that this isn't like an app that you just start up and now you have to figure out the regulations. This is a deeply ingrained effort that is involved with your team and your company in building it and owning it. So it's, yes, the regulations that apply to your operation would be what are guiding the regulatory constraints and inputs and things that are going into the framework that's being built for your organization.
And as I understood, Toby, you are not providing the crew management system. You would somehow embed the crew management system in your architecture. And if you are...
Yep. Go ahead.
And if you are selecting a very modern crew management system like iFlight, for example, then Rajan, to your question, such system has a very powerful and flexible rules engine, and you can exactly have different rule sets based on different union agreements, depending from different geographies. For example, an airline like LATAM Airlines with 9 different AOCs and 8 different aeronautical regulations is working exactly on such a platform. And then depending on which crew and pilot is on board, the system is exactly checking, this crew member can only operate, I don't know, 14 hours, and this one only 13.5. And then you get exactly the right recommendation based on the company rules or the national rules. So this is a bit a no-brainer if you have a modern and flexible system.
Exactly. This is a framework that is identifying where AI can participate, where it can't, and it's mapping the decision making in an organization, and it's what iFlight would be living inside of. It is to enable a powerful platform like that to be adopted and operate, and just defines where it can and can't play, and how it's utilized throughout the organization. So it's exactly intended to be for that, enabling the safe adoption and use of technology and AI. We say AI a lot, but technology and things that are AI, deterministic AI, have been around for years and years and years and years. This is just something that I think is coming more to the forefront of these conversations more urgently because of true AI, agentic AI.
But it's a good example. The question I would say, I would somehow translate in current system is not capable to make this distinction. So that's why we would exactly ask Ryan, okay, why you are doing maybe something at the moment manually? Answer is, because the different regulations are potentially not configured in the current IT system. That's the reason we need to do it like this. And then with a different IT system, we tick the box and the problem is solved. So I think that's a good example. With this assessment, you analyze the root cause of a current limitation. And it's very often not the technology. It is something, let's say it's the technology in place, but not the technology capabilities which are available on the market.
Yep. It'll help operators figure out how to make the technology work for them around how they want decision-making to execute.
This is will lead me to additional question, if I may interrupt, please.
Yes, please.
Gonna be the last question. Is this system gonna affect the man capital in any company?
It gonna affect the man capital? You mean overhead?
Overhead them, and you know, some companies, when you are relying in advanced systems, some of them they start to cutting costs and reducing manpower and so on.
So the short answer is I'm not aiming to make a product that replaces everybody's job. It's actually more human-centric. It's protecting the cognitive workload and defining the decision mapping that comes from humans. And the way it is today, these things are regulated, right? Even if the whole industry said tomorrow, we're going to replace everybody, the regulations don't allow it. It requires human decision making from a regulatory perspective universally across really, maybe except for unmanned systems, and that's a whole nother conversation. But it's more to address a gap that exists. And what I was talking about, a 3-year dispatcher being able to make decisions more like they're a 7-year dispatcher. The inevitability of what's happening down the road is overhead is going to naturally start reducing because we have retiring experienced people. And just like we've experienced in the business aviation over past decade, there's been attrition in experienced pilots, and looking at what do we do for allowing pilots with lower hours and identifying making safety more robust to bring in these pilots that have less hours, or they're getting soaked up by the airlines immediately. But then the airlines have an outflux of retiring pilots. Now they have younger pilots. A 3-year dispatcher is probably making less money than a 20-year dispatcher, right? So if we can make the system safer by empowering and supporting 3-year dispatchers, if that starts to become the norm over the years, we're getting more experienced people with the lower experience. So it's not to replace people, it's to allow for us to continue operating in a space where we may have natural attrition. This is not a framework to tell airlines how to let go all of their dispatchers. It's the opposite.
I would even add to this, and I think nobody is really aware of what we are currently doing to the health of the users. So I get direct messages from people that they suffer high blood pressure, that some colleagues from other airlines passed away, or that there are a lot of frictions. We all talk about collaborative decision making, but we have a lot of frictions because if there's a disruption, people are under stress and so on. And I think we are protecting the well-being of the people in the OCC with a clearer assignment of responsibility, ownership. We ease the communication, and I think this is letting everybody going home with a positive sentiment. So we are not just focusing on crew member well-being or crew member satisfaction. We should also focus on OCC staff satisfaction. And that is exactly what the industry is currently not focusing at all. We are not measuring fatigue. And we are not really looking into the health issues somehow influenced by outdated technology. And we call it hero. They try to do the best, but I think it's not fair to the people that we let them really work in this environment. So we really have to address this. Ibrahim, you raised your hand.
Yep.
Yes, thank you for the talk. It was amazing. To give a little bit about myself, a little bit background on myself. I'm a researcher from Virginia Tech, actually. I'm not from the industry. And it's kind of the first time that I'm exposed to these problems. And I'm working on systems engineering. And a lot of the problems are really familiar to us, actually, to our community. But we mostly focus on, defense applications and whatever. But the logic of integrating technologies in a way that it keeps the human in the loop in a way that the workload is, managed well and also comply with regulations and stuff. I think this is a really good alignment with my community. And as I said, like we're kind of stuck with defense stuff, and we would try to like diversify our research outlets. I think this might be a really good opportunity. I don't know. I don't exactly know how academy and industry collaborations work in your space, but if you're interested in that, I'd be happy to facilitate that conversation with a couple of outlets. Yeah.
I'm always interested in engaging and talking and learning more. You're welcome to shoot me an email. It's on the presentation, or look up my profile and reach out.
Where's the email again? I couldn't catch it.
It's Toby, Toby, at saveflight.ai.
Okay. All right, got it. Thank you.
So we are going to publish the recording tomorrow, and there will be potentially also an article written out of it. And so please connect all with Toby, and please also feel free to join the Airline Crewing and Operations Enigma on LinkedIn, because April will have a double presentation. So after Toby's session today, we have already the next one on the 21st of April. So only 3 weeks from now. And we will talk again also about the neuroscientific angle and cognitive frictions and so on. So I came across Kim also via LinkedIn articles and comments, and we also did a podcast together, and that will be also a very insightful presentation. If you want to give a presentation, just reach out to me. It would be delightful for the community to think outside the box. I think, Toby, you inspire today many people. I think you can only automate if you can articulate. And I think in one of my comments, I said we need to use AI and call it differently. It's not artificial intelligence. It should be articulated intelligence, because this is then putting the focus exactly on the articulation. And if people understand this better, I think AI is also helping more than it's confusing people. Thank you again, everybody, for this insightful also discussion from the audience. Please stay safe and healthy. And if we are not seeing each other the next hours or days, I wish everybody a happy Easter or happy holiday. And thank you very much again. Thank you.
Daniel, thank you very much. Thank you, everyone. Bye-bye.
Thank you.